going to be talking about conceptual engineering and X5. And we're going to be talking about the topic of truth in particular. And this is something that I've done quite a bit in the past on, at least with respect to conceptual engineering. And I'm in the midst of a multi-year X5 project for truth as well. And so what I'm doing today is bringing together these two sorts of projects in, I think, what's a fruitful way, and talking about how they fit together with respect to truth in particular, but then drawing some lessons or having some lessons with respect to philosophy in general. So that'll be the dialectic. We're going to be moving back and forth between conceptual engineering and experimental philosophy, and we're going to be thinking about truth in particular as a case study, and we're going to be thinking about how we can generalize some of these results or some of this method from truth in particular to philosophy in general. One of the projects that I've been trying to promote and defend is the idea that philosophical concepts are, for the most part, defective. So philosophy is the study of what have turned out to be defective concepts. And so the kind of conceptual engineering project that I've presented before with respect to truth, and the one that I'm presenting today, which brings in conceptual engineering and experimental philosophy with also some techniques from artificial intelligence, that could be done in a broad way for pretty much any philosophical concept that you want to focus on. So if you don't care about truth, but you want to think about freedom, or you want to think about reasons, or you want to think about knowledge or consciousness, great. I think the same sorts of problems are going to show up in those concepts, and I think the same sorts of methods can be used to investigate them fruitfully. Okay, so this is very much work in progress, so I'm excited to have any kind of questions during the Q&A period, from, I don't understand anything you're talking about with respect to this stuff, to, how would you do it in this case? So let me go ahead and get going then. So conceptual engineering is the study of how to evaluate and change our representational devices from a sort of philosophical point of view. By a representational device, I mean typically a concept, which is a mental representation, or a meaning, which is a semantic feature of a word or phrase or sentence, some sort of linguistic expression. And conceptual engineering also focuses on not just concepts, not just meanings, but we also think about words and whether they have various lexical effects, pragmatic effects. You can think about a wide variety of representational devices. And you also don't have to be a representationalist to engage in conceptual engineering. So let's say you're an expressivist and you want to think about, say, wrong, the word wrong, or the concept of wrongness. That's perfectly fine. You don't have to think of the word wrong as representing the world in order to engage in conceptual engineering with respect to it. We only talk about, representational devices, for lack of a better term, really, which is things that seem to be about stuff, I suppose. So that's conceptual engineering. Experimental philosophy is also relatively new on the analytic philosophy scene, but it is, of course, a good bit older than conceptual engineering, at least in its current form. Obviously, conceptual engineering goes back to Carnap and Strawson, and earlier than that, almost certainly. And it's had various discussion periods throughout the history of analytic philosophy, but it's only really achieved a sort of independent subject status within the last few years, based on the explosive growth in the number of papers and the popularity of the topic. X5 is the use of empirical methods or experimental methods to investigate philosophical topics or issues. Now, that's laid out in a very broad way, and I want it to be very broad. Typically, experimental philosophy is done by the survey method, which is popular in linguistics, and it's also popular in at least some parts of psychology. The experimental philosophy movement has recently expanded. So we're not just talking about surveys anymore. We can be doing, say, eye tracking studies on subjects, and that's going to be a tool that experimental philosophers might want to use. More recently, we see experimental philosophers advocating techniques like fMRI studies, which would be more common in cognitive science. And we've also seen a decent bit of excitement about machine learning techniques and statistical learning techniques applied in philosophy as a part of experimental philosophy. So, maybe Brian Weatherson's recent online book on using these sort of unsupervised machine learning techniques to identify big picture trends in philosophy. Maybe that counts as experimental philosophy now, with this sort of expanded description of its subject matter, our topic. Okay, so we're going to be doing conceptual engineering, we're going to be doing experimental philosophy, we're going to be showing how these two can work together. It'll be more experimental philosophy as a tool for doing conceptual engineering rather than the reverse. Right? So there's not going to be conceptual engineering as a tool for doing XFi. It's going to be the other way around, XFi as a tool for doing conceptual engineering. And I think it's also an extremely, well, it's not obvious to me that this is just a tool that you can take or leave. It seems to me like an essential tool in the toolkit for the conceptual engineering. Okay, so two things with respect to conceptual engineering. So in conceptual engineering, we need to distinguish two kinds of projects. So there's replacement projects and revision projects. The revision is where you take some representational device, like a concept or a word or a meaning, and you change it in a way, but it still retains its identity through the change. So the concept that you started with, or the meaning that you started with, is still there after the change. It's just undergone a change, like a human being having an arm cut off. It's still the same person. The concept is still the same, even though it's undergone a particular revision. Over here on the replacement side, that's different. No concepts or meanings undergo any changes in a replacement project. Instead, we stop using certain concepts for certain projects or purposes, and we start using other ones for those purposes. Frequently, the other concepts that we use for those purposes are ones that are introduced new, so they are replacement concepts. And the case that I'm going to be thinking about today with respect to truth, the replacement project for truth that I've been defending and working on, I guess, since my time as a PhD student, is firmly in the replacement category, not in the revision category. The truth replacement that I've advocated in the past involves two replacement concepts, and they are ascending truth and descending truth. Now, today, I am not going to defend this particular replacement project. Instead, I'm going to defend a much wider, bigger picture sort of investigation that may or may not justify ascending and descending truth as the proper replacements for the concept of truth, at least for the purposes that I'm identifying. So I'm not going to defend ascending and descending truth as the right replacements, and I'm not confident that they are the right replacements. They are, I think, the best ones that are out there, the best ones that have been investigated so far, but it's not clear to me at all, and I don't think it should be clear to anybody that those are the best, because we simply don't understand what the options are well enough yet in order to say these are the best ones. And that's what this talk is supposed to do. It's supposed to lay out a project or a program for identifying the best or right or proper replacements from among a huge range of alternatives. So it's important to remember in a replacement project, no concepts change. It's our conceptual scheme that changes, because truth, the concept of truth, still sticks around. We're not eliminating it. We're just adding two new concepts, ascending truth and deepening. Okay, so in the literature on truth, for the most part, this is changing to some extent, but it's still a pretty good generalization. It holds pretty well to say that the literature on truth is split into two different families or categories or camps. That's work on the nature of truth versus work on the paradoxes. Now, work on the nature of truth typically is about trying to identify the right conceptual analysis for the concept of truth, or it's trying to identify the right way of understanding the property of being true. So the former, conceptual analysis for the concept of truth, that is a kind of project that goes all the way back to the beginning of analytic philosophy, and we have correspondence and coherence and the pragmatic view, the epistemic view, right? We have deflationists saying it doesn't have a good analysis, and so that's one big branch of bunch of literature on truth. Crispin Wright has a very nice paper called Truth Traditional Debate Reviewed, in which he says, look, we can think about all these theories, correspondence, coherence, and all of those, not as analyses of the concept of truth, but rather as a way of making sense of the property of being true. So it might very well be that the property of being true is identical to the property of corresponding to reality, even though that's not a good analysis of the concept of truth. So that's it's a pretty popular way of thinking about the literature on the nature of truth today, given the decline in popularity of the method of analysis. So reductive explanation, where you're thinking about how to reduce one property to another or explain one property in terms of another, that is thought of, and I think rightly so, as having fewer pernicious commitments than the analytic method. Work on the paradoxes focuses on the liar paradox and a whole bunch of other paradoxes that affect truth. That's what we're going to be thinking quite a bit about today. But I'm not just ignoring the nature discussion, because for the most part, the work on the nature of truth here presupposes certain conclusions with respect to the paradoxes. So if I'm giving an analysis of the concept of truth, then I'm presupposing that the concept of truth is not an inconsistent concept. The analysis I give is a consistent one, in the sense that it's intended to be a consistent principle that doesn't entail everything in the classification. Moreover, if I'm giving a reductive explanation of the property of being true, I'm assuming that there is such a property. I'm assuming that the concept of truth is in good enough shape that it really does pick out a property. So this work here on the nature of truth, in many ways, presupposes certain, I think, implausible assumptions about the paradoxes associated with truth. So although we're going to be thinking a lot about the paradoxes, the investigation directly relates to work on the nature of truth. So just to have an example on the page, we're going to look at the liar paradox. It focuses on a particular sentence. We're going to call that sentence lambda, and it just says lambda is not true. Now, this is the name of this sentence. We could have called it Bob or Jennifer or whatever. That would have been just fine. It's easier to just have a single symbol rather than a name. Now, this sentence says of itself that it's not true. That self-reference is not in itself difficult to understand or problematic, and not a good reason to think that this isn't a perfectly good sentence that has a perfectly good meaning. So we can reason by start off by assuming lambda is true, and we use a certain principle in order to cause some trouble. That principle looks like this. P is true if and only if P. Now I'm being really sloppy here because this has to be a name, this has to be a sentence, so we can do something like that. Of course, that's still sloppy because we don't have a proper name on the symbols here. Those are just single quotes. But I'm assuming that people can follow along and understand how to understand these sorts of principles without going through the rigmarole of defining sentential variables. So we use this. This is called schema T, and it was made very popular by Tarski, and it's used a mainstay in the whole discussion of truth. Liar paradox. From it's true, we can get that it's not true, so we can reason this way, and then from that it's not true, we get that it's true, and that's a contradiction. Now, there are a bunch of other paradoxes that people investigate, not just the liar paradox. One of them is called Curry's paradox, and another one is called Diablo's paradox. And the kind of conventional wisdom in the literature is that these are distinct paradoxes. Curry's paradox is different from the liar paradox, is different from Diablo's paradox. They use different sentences, and Diablo's doesn't even use one single sentence, it uses a whole bunch of sentences. So, but from the perspective that we're adopting today, paradoxes are going to be individuated by the principles associated with truth that are needed to derive them. And in the three cases I just mentioned, the liar paradox, Curry paradox, and Diablo's paradox, it's the same principle. Both directions of schema T are involved in the derivation. So for our purposes, those are going to be three different versions of the same paradox. I don't think a whole hell of a lot turns on this way of individuating paradoxes, but I wanted to mention it so there's no confusion going forward. So the paradoxes are individuated by the truth principles used to derive them. And in the case of the liar, Curry, and Diablo, we're using just this one schema T, or if you like, we're using two principles each direction of schema T. Okay. So now, okay, Manuel mentioned I have a paper that just came out called Conceptual Engineering for Truth. That's in Synthèse, and it's from 2020. It's open access, so you don't need a university proxy to get into it and see it. Anybody can take a look at it. And what I'm going to talk about right now is developed in considerable detail in that paper. There's also a lot more in that paper than I'm going to talk about today. Okay, so we're going to think about how to do conceptual engineering using artificial intelligence. Now, the techniques are from artificial intelligence, and it's the technique that I'm going to show you right now. 3 steps to this. The first step is to identify principles. Identify the principles that you want to look at and consider. These should be principles that you think are important with respect to the concept in question. So for truth, there'll be principles that seem to be central in the way that it works. Perhaps they seem to be analytic in that, It's common for people to think that they're true by virtue of their meaning alone, or they're irrefutable, or they're not the kind of thing that you would go out and confirm a posteriori, right? The kinds of things that you would get for free simply by possessing the concept or by knowing the meaning of the word. So principles, and then identify the paradoxes among those principles, and then we need to develop two classes. And this is the part that comes from work on artificial intelligence. In artificial intelligence, there's a big emphasis on thinking about belief systems and how to revise belief systems, and in particular, inconsistent belief systems. So if some artificial agent ends up with an inconsistent set of beliefs, what should it do? How should it revise those beliefs in a way to regain consistency? And one of the methods, so there's a number of methods in AI, and I'll give you a list of references at the end of the talk, because this is a really interesting and vibrant area that I think philosophers should know quite a bit more about than they do. But one of the techniques is to identify the maximum consistent sets and the minimal inconsistent sets. So the maximum consistent sets, maximal consistent sets, and the minimal inconsistent sets. These are the subsets of your set of principles, and the paradoxes are going to be identified with the minimal inconsistent sets. It's minimal in the sense that if you take away one principle, it's not inconsistent. These are maximal in the sense that if you add one more principle, then it is consistent after that. It is inconsistent after that. So they're maximal consistent sets. You can't add any more principles without going inconsistent. They're minimal inconsistent sets. You can't take any principles away without going consistent. It's this method of maximal consistent and minimal inconsistent sets that's utilized quite a bit by theorists working in artificial intelligence, and that's where I got the idea for this sort of methodology. Now, I want to use an example. This example is based on the work of Friedman and Sheared, and that is work that was done in 1988. So here are the principles. You can see from the share, here are the principles that Friedman and Sheared look at. And in this project in 1988, they said, we're going to look at 12 different principles, and we're going to identify all of the maximal consistent subsets and the minimal inconsistent subsets of these 12 principles. And this has served as a foundational study in the logical investigation of truth and paradoxes since then. I mean, you can see its influence all over the place, but if you're interested, you could see, for example, Hartree Field's massive book, Saving Truth from Paradox from 2008, is heavily influenced by Friedman and Sheared, and he appeals to these results all the way through. So look at some of these principles. So we have P, if P, then P is true. That's called T in. These are Hartree Field's labels, which are kind of, come to be pretty common in literature now. T out, which says if P is true, then P. T inter says if P is provable, then P is true is provable. T exit, if P is true is provable, then P is provable. Because we're using these provability things, you have to have the negations. You can't just get contrapositions on them. T rep, if P is true, then P is true. And T del, if P is true, then P is true. Complete, either P or not P is true. Consistent, it's not the case that both P and not P are true. And then we have universal imbibe and existential excrete. IMB is for imbibe. The idea is that the truth predicate imbibes or sucks in or takes in the logical operator. and in an excrete, it spits it out. So it starts off inside the truth operator and then ends up outside the truth. Inside the truth predicate and then ends up outside the truth. So the universal one, the universal starts out outside and goes in, and for the existential, it starts out in and goes out. We have some assumptions here, which is that truth is preserved under modus ponens. All the tautologies are true, and this mathematical theory that they developed called PRE is also, all the axioms of it are true. It only has one inference rule, which is modus ponens, so all of its theorems are going to end up being true as well. PRE just says that various, it's just a bunch of identities, a bunch of arithmetic identities. And they only use this in order to code up the Gödel numbering and self-reference to get liar sentences. Don't get confused or think this is a deep or interesting part of this project. It's not. It's just to get the self-reference running in this arithmetic language. Okay, so I'm going to stop sharing that. And let's look at the results. Okay. Hopefully everybody can see that. Now, you can see the principles. You see 6 principles on the left, 6 principles on the right, and all of the lines in there are inconsistencies. These are minimal inconsistent sets. So the dotted lines, that is, are all the inconsistencies. So you can see the dotted line running across the top. That's the regular liar paradox, T out, T in. But there's lots of other ones in here that don't have any names. For example, you can see a dotted line running from T out to T comp on the right-hand side. That paradox doesn't have a name, but it's there nevertheless. And we also see 2 entailments, which allow us to cut back on the number of explicit paradoxes. Obviously, since E excrete implies T comp, the paradox is associated with one or anything. So in total, we have 27 paradoxes hiding in these 12 principles. 27 distinct paradoxes hiding in these 12 principles. And remember, I'm individuating paradoxes by principles involved in the derivation. So this isn't Bayer, Curry, Yablo individuating. Those all count as one paradox. That's the top paradox on this chart here. All the rest of them involve different principles, not the schema T that the liar involves. Okay, so those are the minimal inconsistent sets, and Friedman and Sheared do a wonderful job of identifying the maximal consistent sets. Here they are. I've labeled them A, B, C, D, E, F, G, H, and I. There are 9 maximal consistent sets. The largest 2 have 8 principles, you can see. So that means there are no consistent sets that have 9 principles, 10 principles, 11 principles, or 12 principles. There are only, so there's what, 495 subsets. 495 subsets that have 8 members, but only 2 of those are consistent. Only 2 of the almost 500 subsets that contain 8 principles are consistent. That should kind of get you in the mode of feeling how deeply inconsistent the concept of truth is here. This is not something that you appreciate simply by thinking about the liar paradox, Curry paradox, Yablo paradox, the standard ones that have names that are thrown around in the literature. You can't get an appreciation for this depth of inconsistency in our concept by simply thinking about the paradoxes that show up in the literature. Instead, we have to do this sort of technique or this sort of move in order to get a feel for it. All right, so this is supposed to be an example. I'm done sharing now. Okay, good. And so from that example, we can draw some important conclusions. First, if we are thinking about replacing the concept of truth, then this method tells us what our options are. Our options are right here. The replacement concepts that we might invoke are the ones that we might say, this should be a concept to replace the defective concept of truth. Those are all going to be defined by the maximal consistent subsets of principles. That is, if we want a consistent replacement. So the maximal consistent subsets of your principles will tell you what your options are for replacement. We think of each maximal consistent set as providing principles that are constitutive of that concept. So because we have 9 maximal consistent subsets of the Friedman Sheared principles, we have 9 potential replacement concepts for the concept of truth that they've identified. Now, it turns out none of these are very good replacement concepts because of some of the assumptions that they make. And that's fine. They were working back in the late 1980s. They didn't have all the work that's been done between then and now to rely on. And it's a groundbreaking study that has inspired a whole number of, or I guess, generations of theorists in the truth literature. Nevertheless, it serves as just kind of an example for my project because it's not big enough and they don't have all the right principles in there in the study. Once we have maximal consistent and minimal inconsistent subsets, we can use some measures from the artificial intelligence literature and rank or evaluate some of these principles for whether we want to keep them in our replacement concepts or dump them and not have them among the constitutive principles for the concept that we use to replace the defective one. So the measures, one measure is incon, which is the number of inconsistencies that the principle is involved in. If you think back about the diagram for the Friedman and Sheared ones, this would be how many arrows are going into the principle, right? How many inconsistencies, how many paradoxes is it involved in? That's incon. Now, incon can be measured in multiple different ways. We can measure it by saying, well, every paradox just counts as one, or we can do a bit more sophisticated thing. So if we have 2 principles, 2 of the principles that give you the paradox, then count it as 1. But if you have 3, then count it as less. If you have 4, count it as less. If you have 6, count it as less. The idea being, if you need more other principles in order to get your paradox, then that counts as not as bad with respect to that principle. There's quite a range of options here when it comes to thinking about how to rank the principles for how bad they are and how problematic they are. Another one is max-con, which is how many maximally consistent sets is the principle a member of, divided by the total number of maximal consistent sets. So that would be a measure that tells you, how much you're getting away with by having that principle be among those that are constitutive of your replacement. Okay, now from Friedman and Sheared, we can generalize the project in a couple of ways, but the number one way that I want to generalize it is by including far more principles. So here I'm sharing sorry. Good, okay. So here are disquotational principles, and you can see the bold ones are ones that show up in Friedman and Sheared. So we have in, out, intro, limb, just like a lot of those that we looked at from Friedman and Sheared. We have compositional principles, so that not, P is true, if it's not the case that P is true, then not P is true, is the first one. The second one says if not P is true, then it's not the case that P is true. And we can think about these other ones as well, right? So conjunction's true, then both conjuncts are true. If a disjunction's true, then one of the disjuncts is true, and so on. We can think about exclusive and exhaustive principles, which say that everything is either true or not true, and nothing and its negation are both true. We can think about implication principles, which say, if this conditional in the antecedent holds, then the truth ascription to the premises and the truth ascription to the consequent, sorry, the antecedents and the consequent, that conditional also holds. Lots of different options here. For example, if two sentences are materially equivalent, then the truth ascriptions are materially equivalent, or vice versa. Deduction principles, all the tautologies are true, contradictions are not true, truth's closed under modus ponens, closed under modus tollens, closed under double negation elimination, closed under hypothetical syllogism, and so on. Quantification principles, these are the ones that are the trickiest to translate into English, and there's really not a good way to translate these guys into any kind of English that anyone's really going to understand if you utter these sentences. That's one of the tricky aspects to the project. Theory principles, so something's, if one of these principles is on the list, then it should be, the claim that the principle is true should also be on the list. And then finally, mathematical principles. So, maybe you want all the axioms of theorems of piano arithmetic are true. Or maybe you want all the theorems of Zimmermann-Franco set theory or ZFC or whatever are true. Okay, so that's the number one generalization. And you can see that for the most part, when I'm looking, so for the most part, when you see what we're looking at here, we're looking at how the truth predicate interacts with logical vocabulary and also how it interacts with, to some extent, some metalogical vocabulary like provability. And that's about it. So it's really just the logical behavior of this predicate that we're investigating here. And there's nothing special about truth in wanting to know how it interacts with these logical expressions. I think it would be a normal thing to investigate in any predicate that applies mostly to sentences or propositions. Okay, so now what I want to bring out is the importance of X5. Now, so far we have principles. We have the method of maximum consistent subsets and minimal inconsistent subsets. And we have some measures for those principles like incon and maxcon. And that's from artificial intelligence. But now, I want to emphasize the importance of doing XPhi on these principles. And by doing that, I mean studies that are asking the general public or people who are native English speakers, English here in this case, but cross-linguistic studies would of course be a part of a bigger project here. So we're looking at studies of English speakers, and we want to know two things. One, how plausible is each of those truth principles according to the English speaker, right? So what's the difference in plausibility between if a sentence is true, then that sentence, so if P is true, then P, something like that, versus something like if a conjunction is true, then both conjuncts are true. We can test and we have been working on using a number of platforms here to test the responses of native speakers to these sorts of principles, and there are some differences in plausibility. We also plan on testing these principles for constitutivity. How much do people think that these principles are constitutive of the concept involved? I'm happy to talk about how those are going to go. That's a different kind of experiment that has some more complex theoretical assumptions built into it. But xphi here is useful in conjunction with our logical measures to help pick replacements. Help pick replacement concepts. So ultimately, other things being equal, we want our replacement concepts to be constituted by principles that show up in a wide range of the maximal consistent subsets, that are involved in fewer inconsistencies, that everyday folks think are more plausible, and that everyday folks think are more constitutive of the concept of truth. So the more plausible the principle is, the more reason you have to preserve it in the replacements. The more constitutive a principle is of the concept of truth, the more reason you have to preserve it in or among the replacements. Okay. So now we're now on time. Let me go into some challenges for this kind of project. So challenges. So from the conceptual engineering, no, actually, sorry. From the logic side, there are a number of challenges here, and they are, if we don't include certain principles in our study, then there's no way we can use those principles to decide on which concepts to adopt. For example, Friedman and Sheared don't say that the extension of the truth predicate should not include the entire domain. Okay? So they don't say anything like, hey, I know this seems obvious, but it's not the case that everything is true. It turns out that their subset A does have everything being true. So, we can use some sort of criteria on top or in addition to or extrinsic to our logical investigation to decide on some of these. Another issue will be omega consistency. Some people working on axiomatic theories of truth think that omega inconsistency is not a big deal. I think it is a big deal. Remember, omega consistency is something like we have a predicate and we prove that the predicate holds of 0, it holds of 1, and it holds of all the natural numbers. But we can also prove that there exists in X not P X. And this isn't a flat contradiction. It's called a omega inconsistency. And I want to encourage you to think that omega inconsistent theories are problematic, that this is a massive cost, and I think should be rejected. Another option, another worry or challenge that we come across is dialetheism. Some of these sets might turn out to have contradictions be true, and that's actually what happens. Subset G of the Friedman and Sheared study is dialethic. It's not inconsistent, right? The principles are consistent, but the extension of the truth predicate according to those principles is inconsistent. Now that inconsistency can't pop out from inside the truth predicate to outside and infect the whole logical system, but having truths that are contradictions, I think, should count as a cost regardless. Now, for xphi. So xphi. Big challenges here. Good data. Having good data, finding good data, collecting good data is really tricky. And we've been running a ton of preliminary studies just to make sure that we're getting clean data, that we're not getting anomalies, and trying to make sure, by talking with experts on experimental design in both psychology and linguistics, that we're not getting, priming effects or other sorts of biases, cognitive biases that show up all over the place in this sort of study. So trying very hard to make sure that we get clean data and that we're not biasing our data by the way that we ask questions of the folks who are taking part in the studies. Another big issue, the logical vocab. So when I provide a study to somebody, that study is going to have vocabulary like and, or, not. What kind of assumptions can I make about how people understand that vocabulary? Is it just straight up first order predicate calculus, or is there something more complex there? The answer is there's something more complex there, but you have to tease those effects out. Another issue is translation. Translating from logic into English is not easy. And doing it in a way that's reasonable for an everyday person who isn't a logician, doesn't have a lot of logic training to be able to understand, not just some sort of big, long, complicated, stilted English sentence. You have to get something that's fairly natural so that they can assess it for plausibility. That is really hard. There's lots of ways to go about translating these things into English. Some of them end up being more plausible than others, even though they seem like they should be logically equivalent. That's one of the things that we've run up against as well. Now, here's the big topic here, which is intuitions. Intuitions. Are we studying intuitions here with this application of experimental philosophy? And I want to encourage you to think that the answer is no. We're not doing anything that can be, I think, plausibly identified with either the positive project or the negative project. So the positive project is using experimental philosophy to identify intuitions that can be plugged into a kind of philosophical analysis or conceptual analysis. So identifying intuitions that then serve as a basis for philosophical analysis or conceptual analysis. We're not doing that at all. The negative project, undermining philosophers' appeal to or defense of intuitions in the role of doing analytic philosophy. We're not doing that either. So we're not vindicating intuitions and we're not attacking intuitions. This just doesn't have anything to do with this huge topic in X5, which is it positive? Is it negative? What role do intuitions play in philosophy? What role should intuitions play in philosophy? There's none of that stuff. Right? I don't know whether when linguists use mechanical Turk to get judgments about sentences and sentence construction, particular ways of analyzing them, are they studying people's intuitions? That's a question that I don't really care that much about. It's not, nothing really hangs on whether we're studying intuitions or we're studying responses or whatever. So I think it's helpful here to think about the role that X5 plays in this larger conceptual engineering project, because it gives us a different perspective on what X5 can do, what X5 studies can do. They don't have to be a part of the positive project. They don't have to be a part of the negative project. We're not indicating new ways of conceptual analysis. We're not criticizing philosophers for their appeal to intuition. We're doing neither of those things. Instead, X5 is being used to evaluate principles that might or might not get incorporated into various replacement concepts. So this isn't a positive project or a negative project. It's an evaluative tool that can be utilized by conceptual engineers in order to identify the best replacement concepts for whatever kind of project they're engaged in. All right, now, finally, the other thing is, another big issue in this intuitions debate is, are philosophers experts? Okay, again, we don't care about that. That is an issue that just doesn't come up for this use of XPhi in conceptual engineering, right? We're not worried about the expertise issue. That issue is just completely beside the point of this application. So again, a major topic in experimental philosophy, right? The status of professional philosophers as experts just doesn't even show up on this fuel tool. And then the last thing, this is, I think, where there is quite a bit of action in conceptual engineering already, but this sort of project gives a different perspective to it. And this will be the second to last thing before I stop. This is teleology. So why are we doing this? Why are we doing the conceptual engineering? What's the point? Who cares? Why do this? So you'll see conceptual engineers appeal to all sorts of teleological projects here. You know, maybe the purpose of the concept or the word or something like that. Certain conceptual engineering projects do appeal to something like the purpose of a project. Herman Kaplan is, in his book, Fixing Language, has argued against those sorts of appeals, and I pretty much agree with him on that. For my own part, I don't assume that concepts or words or meanings have built-in purposes. Instead, I like to look at projects. By a project, that's just something somebody wants to do. Nothing more to it than that. It doesn't have anything to do with, you know, some intrinsic feature of the concept of the word. It's just something some person wants to do, something somebody wants to accomplish. And the ones that I've focused on mostly are natural language semantic projects, and in particular, truth conditional approaches to doing natural language semantics. So for me, everything comes down to what's going to be a good replacement team. Which team of concepts will replace truth in a way that allows us to do natural language semantics in a truth conditional way without deriving any contradictions or inconsistencies via the paradox. So a paradox-free way of doing something like truth conditional semantics, but utilizing the replacement concepts instead of the concept of truth, so as to avoid contradicting ourselves when we do semantics for expressively rich languages, ones that can formulate sentences that give rise to the paradoxes, sentences like the liar and others. And then that's the name of the game here for me. Now, finally, the last step. The step from, this is the hey guys, I made a hammer and now I'm going to go wander around the world looking for nails step. This is the move from thinking about truth as a defective concept and what to do about it, how to best replace it, to the claim that philosophy in general is the study of what have turned out to be defective concepts, and how to use this same strategy to investigate and study how best to replace all the other concepts that philosophers engage with. Now, I haven't said how to go about doing this transition, but again, it's going to be essentially the same steps that we've seen already. Identify principles, identify the paradoxes among them, generate your minimal inconsistent sets of principles and your maximal consistent sets of principles, run your diagnostics, do your XPhi, identify the best maximal consistent sets, those are your replacement concepts, and then based on your teleology, select a set of replacement concepts for that purpose. So overall today, I've laid out two kind of big projects associated with truth. One is a logical project, trying to understand the inconsistencies and consistencies among 50 or so different principles associated with truth. The other is an experimental philosophy project, appealing to non-experts or just native speakers' intuitions about plausibility and constitutivity in order to help identify which concepts we ought to use to replace truth. Now, I've advocated, again, ascending and descending truth as the right replacements. The entire premise of this talk has been that I'm not sure that that's the case. I'm not sure that those are the best ones. They're the best ones that, you know, some random guy sitting in his armchair thought up, you know, a decade ago or whatever. You know, it seemed best to me. But is that really the kind of thing that should convince you? No. Instead, this sort of study that I've advocated here today is the sort of thing that should be able to convince a wide swath of people that certain suggestions for replacements are in fact the best way to go about changing our conceptual scheme to deal with the defective concept that we found ourselves invested in. All right, so that's it for me. Thanks very much.